Before we talk about solutions, it's important that we review what molecules are polar or nonpolar. So if you'll stop the video and go through this and classify them as a review. Okay, we're back. On the very first molecule, this one is nonpolar. We have a carbon-carbon bond and we have a carbon-hydrogen bond. If it's bonded to itself, this is a nonpolar bond. If it is a carbon-hydrogen bond, this is a bond that you should have memorized. This is always nonpolar. I'll quickly sketch out this molecule. So we see that in this molecule, I only have nonpolar bonds, so that makes the whole molecule nonpolar. Let's do the next one, carbon tetrabromide. I'm not going to put the 3 unbonded pairs around the bromine, but they are there. So on this one is also nonpolar. So this is a case where I have a symmetrical molecule, I have the same bond all the way around, and so if I have the same bond all the way around, it will always be nonpolar. And for my third molecule here, I have 3 bromines and 1 chlorine. So you can see here I don't have the same bond all the way around, and because of that, this is going to be a polar molecule. So the chlorine is going to be a little bit electronegative, and we're going to see that it's going to be a little bit negative on this side and a little bit positive on that side. So this is a polar molecule. And our last one there, this one is also polar. It actually is ionic. When something is ionic, we have a cation and an anion. So this is a case of extreme polarity. I have a positive and a negative ion. So that for sure is a positive and negative sign. All the ones up above, these ones are all covalent bonds. Covalent bonds share electrons, and it is when a nonmetal is bonded to a nonmetal. Your ionic is when you have a metal bonded to a nonmetal. So ionic will always be polar. Here's a slide that just reviews what we just talked about. Again, ionic is a metal bonded to a nonmetal, or it could be a polyatomic ion, or maybe even 2 polyatomic ions. Regardless, that will be ionic. I'll have a cation and an anion. That will be polar. Covalent, we're sharing electrons. It can either be unequal sharing, and if that is the case, it will be polar. If I have equal sharing, if I have an atom bonded to itself, or I have a carbon-hydrogen bond, or I have the same bond all the way around a central atom, all those cases, it will be nonpolar. Here's another quiz you can test yourself on. So classify these 6 molecules as polar or nonpolar. Stop the video and see if you can do this set. Okay, we're back. So quickly going through these, this one will be nonpolar, and this one will be nonpolar. So in both of these, I just have carbon and hydrogen. And so remember, the carbon-hydrogen bond is always nonpolar, and carbon bonded to itself in that first molecule will also be nonpolar. Ammonia is polar. I can sketch it out. It has an unbonded pair. Anytime you have an unbonded pair, it will be polar because it's not the same bond all the way around. And my O2, it's bonded to itself. This is nonpolar. And the 2 on the bottom, they are both ionic. And the video might have cut it off, but we have a metal with a polyatomic ion, and then a metal and a nonmetal. So because it's ionic, then it will be polar. All right, let's go through the types, kinds, and concentrations of solutions. Matter can be split up into homogeneous and heterogeneous. So again, homogeneous substances, there's a lot of sameness. Heterogeneous, you can see different colors, you can see different particles. So there is a definite boundary. So even a glass of ice water, this would be a heterogeneous mixture because I have 2 different phases. Again, homogeneous is a lot of sameness. So it's composed of pure substances that we find on the periodic table with elements. And then when we combine those elements into compounds, those are also homogeneous substances. And then we come to our homogeneous mixtures. Homogeneous mixture, another name for that is a solution. And that is what our unit is talking about homogeneous mixtures or solutions. So in a solution, it can't be separated out. It will always stay mixed. The particles are really, really tiny. And as long as it's in a closed container, it will never settle out. You also can't use filter paper to try to separate out what you have dissolved into solution. In your solution, it is composed of solutes and solvents. So the solute is what is dissolved. The solvent is what does the dissolving. Also, if you have two liquids or two gases, whatever is the smallest in quantity, that would be the solute, and whatever's greatest in quantity, that would be the solvent. And our most common solvent is water. So water is known as the universal solvent. So if I were making up some Kool-Aid and I would put in some sugar into the water, and the Kool-Aid powder and the sugar, that would be my solute, and the water would be my solvent. So there's a lot of S's here, and how I remember this is I remember alphabetical order. U comes before V, so the U in the solute goes into the V, and so that's how I remember it. So solute goes into solvent and gets dissolved. All right, how something is dissolved. There's a link that I have included after this video that you can watch an animation of water picking apart an ionic solid. But whenever you take, for example, a salt or an ionic solid and put it into water, the first thing that's going to happen is the water is going to surround the solute. If it's any solvent, it would be called solvation, where the solute is surrounded by the solvent. If I'm using water specifically, you can also call it hydration, where I have water molecules are surrounding my solute. And what we will see is that ionic solid, I have both negative particles and positive particles or ions, and the water will orient itself around the ions with opposite charges. So when we look at a water molecule, we see that by the oxygen, it's negative, and by the hydrogens, they are positive. So when the water surrounds your ion, right where the hydrogens are, that's where you're going to have your anion. And so it's going to orient itself opposite charges attracting. So just like this picture here, so around the cation or the positive ion, we have the oxygen part of the water will surround that. And then around the negative particle, we'll have the positive hydrogens surround that. And then after they surround the salt or go through that hydration or solvation, dissociation will occur. The water will actually pull those ions apart. And I will get, just like what this picture is showing right here, I will have a single ion surrounded with water. So again, that's called dissociation, where the ions are separated from each other. So in class, I do a little demonstration, and we have 4 types of solutions. So I use 2 types of solvents. So I'm going to use water in the first 2 test tubes and hexane in the second set. And then for my solute, I'm going to use copper sulfate and iodine. And so we're going to look and see if we can make solutions. After this video, I have attached a YouTube video that goes through this same demonstration and shows you what I did in the classroom. So in my first test tube, again, I have my water, and I'm going to put in my copper 2 sulfate. So copper 2 sulfate, it looks like this. Okay, so we have a positive ion and a negative ion, or a polyatomic ion. That's what we put in there. And this is a bluish crystal solid. And we find that, yes, it does make a solution. And I'll color it blue. Okay, so that's our first test tube. Our second test tube, I add iodine into water. And even after you mix it up, right at the bottom, it just is sitting there. Nothing happens. And then in my third test tube, so now I have a different liquid, and I'm going back to my copper 2 sulfate, and I add my copper 2 sulfate, and it just sits there at the bottom. Nothing happens. So in both of these cases, I do not form a solution. And let's look at our very last test tube. So we have iodine in hexane. If you look at iodine, it's bonded to itself. So this is what iodine looks like. And when I put it into my hexane and I try to stir it up, I find that it makes a purple solution. So does this form a solution? And the answer is yes. So how come I can form some solutions, but then some combinations don't make a solution? They won't dissolve. Well, it has to do with polarity. So in my first case here, I took a polar water molecule and then I put in a polar salt. And notice that I get a solution. And I didn't get a solution in the two middle test tubes, but in the last one, I find that I have a nonpolar solute and I put it in a nonpolar solvent, and I also got my solution. So sometimes this is described as like dissolves like. I prefer to look at it that you have to have similar polarities. So you have to have similar polarities to make a solution. Here's a visual just to kind of put it in your mind. So again, when making solutions, the polarities must be the same. So in my first picture, I have a polar bear with a polar bear. So they're both polar. So a polar solvent dissolves a polar solute. And in my second picture, I have non-polar bears. So that's to remind you that non-polar solvents dissolve non-polar solutes. And your other combinations with a polar solvent and a nonpolar solute, or a nonpolar solvent and a polar solute, they will not form a solution, but you can try to combine them anyway. All right, let's talk about different types of concentrations now in solutions. So a lot of times when you're looking at a colored concentration, you can tell what is more concentrated just by the hue. And this would only be for colored concentrations. So for example, in my first test tube, I might have a light blue. In my next one, it might be a little bit darker. And then in my third one, that might be my darkest. So we know that just because of the color, that the concentration increases. This doesn't apply to all solutions, because sometimes when you're dissolving a solute, you just get a clear and colorless solution. So if you think of like some salt water or some sugar water, it just looks clear and colorless. So with the case of salt and sugar, that's something we can consume. You might have to do a taste test. So which one's the most sweet would be the one that's the most concentrated. So we can use color or taste if we're using our household things that we're making solutions. But in chemistry, we can split solutions into three different types of concentrations. And they are unsaturated, where my solvent can hold more solute. They are saturated, when my solvent can't dissolve any more solute. And a good example of this is, for example, if you have Cheerios and you would like them to be sweeter, you can go and add a spoonful of sugar to your milk and your Cheerios and stir it up, and then you eat your Cheerios. And what do you have left at the bottom of that bowl? You have a sugar sludge. So this means that the sugar didn't all dissolve in the milk. So you kind of have some leftovers. So this is a saturated solution that you made with your milk and your sugar. The third type of concentrated solution would be a supersaturated solution. So this is a solution that contains more solute than it's supposed to hold. That's because if you heat it up and then you cool it down, you can dissolve more solute than you should. And so you kind of trick it to holding more. If I have a clear and colorless solution, I might not be able to figure out if my solution is unsaturated, saturated, or supersaturated. So I have to perform a little experiment on it. And I do this by adding a crystal. So if I add a crystal to unsaturated, I get that crystal to dissolve. And so that tells me it's unsaturated. If I add a crystal and it just floats to the bottom and nothing happens, that's a saturated solution because it can't hold any more solute. And for a supersaturated solution, if I get more crystals appearing, then that tells me that I have a supersaturated solution. So what happens is when you add that crystal, it jars it out of all that solute being dissolved. And so more crystals will appear, or we can say that the solute is falling out of solution. All right. And I will link a video of a supersaturated solution after this video. Let's revisit a saturated solution. So a saturated solution is at equilibrium. So the solid that's right here at the bottom, it looks like nothing's happening, but we actually have continuously dissolving and then recrystallization forming. I will have solute dissolve and go into solution at the same rate as it will come back and form my crystal. And so you usually draw it with these little arrows. So again, I will have solute leaving at the same rate as it goes back and forms your solid.